Hi everyone, and welcome to our first series of visual lectures for EEE 1-to-1 Data Structures and Algorithms. So we're now in the second half of our course, and we'll start off with the topic of graphs. Okay? So what is a graph? So a graph is an abstract data type consisting of a set of nodes and a set of edges. Okay? And each edge in a graph connects a pair of nodes in the set of vertices. Okay, so we're already actually familiar with the concept of nodes and edges from our discussions on trees. And that's because trees are actually a special type of graphs. Okay, um, for example, we can have a graph defined as follows. Again, set of nodes and set of edges. In our set of nodes, we have 6 nodes, okay? A to F, and we have 8 edges, okay? We say that there's an edge between node B and node F, there's an edge between node F and node C, and so on, okay? So here, I've implemented some Python code, and let's see what our graph looks like, okay? I've imported libraries, and we've added nodes and edges, and we drew the graph, okay? So in our graph, again, we have 6 nodes, A, B, C, D, E, and F. And based on the edges defined in this set, we see that there's an edge from B to F, from F to C, from B to C, and so on. Okay? So why do we need graphs? What are they used for? So we use graphs to represent connections between similar objects. Okay? So some applications of graphs, we have our circuit analysis. Okay? So when we have simulation software such as Symmetric, Simulink, then we can represent nodes. We're familiar with nodes from our node voltage analysis as actual nodes in our graph, and we can represent edges as our components. Okay, and based on the values of our components, our resistor values, capacitors, sources, and so on, we can see what the voltage is between any two nodes, or what the current is flowing through an edge, and so on. Okay, so another application of our graphs is for navigation. So we have applications like Waze or Google Maps that help us find routes when getting from one place to another. And in these mapping software, we can represent locations as individual nodes and paths, okay, or our roads as edges connecting 2 points. And if we want to get, say, from this point to that other point, then we actually have several options. So kita natin dito, the direct route is the physically shortest route, pero traffic siya, okay? And we can try to find alternative routes based on the edges in the graph. Another example that's very relevant to our situation now is contact tracing. Okay, so when we have individuals who are infected or being investigated in an epidemic, then if we want to try to contain the incidences, then we can try to identify who has this person been in contact with, and how do we mitigate the spread of the virus. How do we keep these people contained or away from the general population? Okay? So that's our introduction on graphs. In the next video, we'll talk about some types of graphs and more definitions on graph theory. Okay?